Just a few more questions for you on evaluating functions, and then we're going to look at some theoretical pieces that go along with this. So let's say we have a function that describes bacteria growth. In this particular function, n, the letter n stands for the number of bacteria as a function of time. As a function of time. So n of t, number as a function of time. And let's just presume that maybe time is in hours. In this problem, 500 is the starting number of bacteria in an experiment that some scientists are doing. So let's say that we want to evaluate this using a table, and for time we want to put in 0 hours, 1 hour, 2 hours, 3 hours, 4 hours later. And our output will be n of t, or the number of bacteria. So if I put a 0 into this equation, I take 500 times 1.5 to the 0 power. Well, remember, you do powers first, and any number raised to the 0 power is 1. So what we have here is 500 times the number 1. So the output for that is 500. Well, that makes sense. If there's no time in this experiment and we started with 500 bacteria, then we still have 500 bacteria. When I put a 1 into this equation, 500 times 1.5 to the first power, I just need to take my calculator and type 500 times 1.5. Don't need to bother with that 1 power. So let's go 500 times 1.5, 750. So I get an answer for that. When I put a 2 into this function, 500 times 1.5, I want to square that 1.5. So I'm actually going to type that in the calculator as you see it. So 500 times 1.5 to the second power, and that tells me we'll have 1,125 bacteria after 2 hours. And so we're evaluating this function for some input values. Please remember, I could have just gone to the calculator, let's see, right here, and I could have hit the y equals key, cleared the old function, and gone 500 times 1.5 to the x power. Instead of doing those calculations by myself every time, I could put that in there and then go second and the window key to start the table at 0, because I've asked you to put in a 0, a 1, a 2, a 3, a 4, and let's go in increments of 1. So start the table at 0, go in increments of 1 automatically, and let's go second graph key to see the table, and we see that with no time, we still have 500 cells. 1 hour, we have 750. 2 hours, we have 1,125. 3 hours, we have 1,688 cells, etc. We're going to work towards our way of graphing functions, and we will get to these applications like this and talk about graphing time on the x-axis and number of bacteria on the y-axis, but having this as a tool and that table feature will be very, very helpful. So look at number 10. Say you wanted to evaluate your income as a function of the hours worked, and your pay value was a function of hours, and you were getting paid $8.75 per hour at some number of hours. So let's say we decided to put 0 hours, 10 hours, 20 hours, 30 hours, 40 hours into the function machine to find out what our pay would be. We could just go here, hit our y equals key, clear that equation. Again, it was $8.75 for x hours. And I'd go second window to set up my table, and I'd start it at 0, and I'd ask it to go in increments of 10 hours now, because I'm going to go 0, 10, 20, 30, 40 automatically. And now I'll go second and hit the graph key, and I see that if I work 0 hours, I don't get paid. If I work 10 hours times $8.75 per hour, I get $87.50. 20 hours, 175, and I can fill in this table. So 0, 87.5, 175, I believe that was, you know, etc. So I'm evaluating a function, and I have all kinds of real-world scenarios where my paycheck is dependent on the number of hours that I work. Okay, I'd like to share one real theoretical difficult topic here, and this is like homework problems 5 through 12. No numbers involved. I'm going to ask you to write a formula to express the circumference of a circle as a function of its radius. Circumference of a circle as a function of its radius. That's what that sentence says. Well, it happens that I know from previous work that the formula for the circumference of a circle is 2 pi times the radius. And I'm all done because this equation is in terms of the letter r. It is c is 2 times pi times r. But if I wanted to take this equation and write it over again with the letter d instead of the letter r, I could replace this letter r with a d divided by 2, because isn't the diameter cut in half of a circle? Isn't that the radius? You know, here's a circle. Here's the radius. The diameter is all the way across, so you cut that diameter in half. The diameter cut in half is the radius. So I have 2 times pi times the diameter divided by 2. And so if I cross this 2, which is in the numerator, off, and this 2, which is in the denominator, because they're equal to the number 1, I am left with pi times d in this equation, pi d. The circumference is now expressed as a function of the diameter, and the new formula for that is pi d. Let's do it again. For the edge of a cube as a function of its surface area. So remember, a cube looks like this, kind of. All right, and its edge is E. And its surface area, remember here's an edge as well, so one side of the face of a cube, its surface area would be E times E, or that would be E squared. But there are 6 faces on any one cube. There's one up here, there's one over here, and you can't see the other 3 sides, opposite the red and opposite the blue and opposite the black. So there are 6 of those faces representing this total surface area of a cube. This one asks us to write the edge as a function of the area. So I have this equation, and what they want me to do is they want me to get E alone. They want me to solve for E so that I can write this equation as E by itself is a function of A. So to get E alone, I'm going to divide both sides by the number 6 first. And when I do that, these 6's cancel out, and I have A divided by 6 equals the edge squared. Again, I want to solve for E, and I can't have E squared in order to solve for E, so I've got to take the square root, because the square root of E squared would be E. So I've got to take the square root of this side as well, and so finally I have E is equal to the square root of A over 6, and true enough, I have written this formula, so the edge is a function of the letter A, and again, it's the square root of A over 6. That's all I'm going to bother you with for now until you come in and we have time for questions. Done with Chapter 3, Section 1, which is an introduction to functions.